Today in this video, let us learn about the comparison between the center tapped and the bridge-way rectifier. Now moving on to the topics, before going to the comparison table between the center tapped and the bridge-way rectifier, let us learn a little bit about the center tapped full-way rectifier. Now if you see here, this is a circuit diagram for the center tapped full-way rectifier, in which when an additional wire is connected across the exact middle of the secondary winding of the transformer, then it is known as a center tapped transformer. So here we can observe the additional wire which is connected across the exact middle of the secondary winding. So that's why in the case of the center tapped full-way rectifier, we make use of center tapped transformer. And the center tapped full-way rectifier uses a center tapped transformer to convert the input AC voltage into the output DC voltage. And during the positive half cycle of the input AC signal, the diode D1 is forward biased and it allows the electric current through it, whereas the diode D2 is reverse biased and it does not allow the electric current to pass through it. So that's why if this is the AC input signal which is given as input to the center tapped full-way rectifier, then during the positive half cycle of the input signal, the diode D1 is forward biased. That's why it allows the electric current to pass through it, whereas the diode D2 is reverse biased. That's why it doesn't allow the electric current to pass through it. Whereas during the negative half cycle of the input AC signal, the diode D2 is forward biased and it allows the electric current to pass through it, whereas the diode D1 is reverse biased and does not allow the electric current to pass through it. This is just opposite to that of the positive half cycle of the input signal. So that's why the rectified load current flows during both the positive and the negative half cycles of the input signal, due to which we get the full wave signal across the load. Now let us see what are the advantages of the center tapped full wave rectifier. The first one is the DC load voltage and the current are more than that of the half wave rectifier. There will be no DC current flowing through the transformer windings, hence there will be no possibility of saturation, and the efficiency is very high in the case of the center tapped full wave rectifier, and it has less ripple factor. Now let us see what are the disadvantages of the center tapped full-way rectifier. The first one is the PIV rating of the diode is high, by which the higher PIV diodes are larger in size and they are costlier. Due to this, the cost of the center tapped transformer is high. The next is the bridge-way rectifier. Now let us see how we can define the bridge-way rectifier. A bridge-way rectifier is a type of the full-way rectifier which uses 4 or more diodes in a bridge circuit configuration to efficiently convert the alternating current into the direct current. Now if you see here, this is the circuit diagram for the bridge-way rectifier, which makes use of 4 diodes like D1, D2, D3 and D4. So during the positive half cycle of the input signal, the diodes D1 and D3 are forward biased and allows the electric current, while the diodes D2 and D4 are reverse biased and they blocks the electric current. So if you see here, this is the AC input signal. So during the positive half cycle of the input signal, the diodes D1 and D3 are forward biased, so they allow the electric current to pass through the diode, whereas the diodes D2 and D4 are reverse biased, so they block the electric current to pass through the diodes. Whereas during the negative half cycle of the input signal, the diodes D2 and D4 are forward biased and allows the electric current to pass through them, while the diodes D1 and D3 are reverse biased and it blocks the electric current to pass through the diodes. So this is just opposite to that of the positive half cycle of the input signal. Hence the output voltage is produced same as that of the full wave rectifier, that is, it produces the positive half cycles of the input signal. So that's why we get the resultant DC output for the bridge wave rectifier as a continuous positive half cycle of the input signal. Now let us see what are the advantages of the bridge wave rectifier. The first one is the current in both the primary and the secondary of the power transformer flows for the entire cycle. That's why the power transformers are small in size and less in cost. In the case of the bridge wave rectifier, there is no center tap is required in the transformer's secondary, and as 2 diodes conduct in series in each half cycle, these circuits can be used for high voltage applications. Now coming to the disadvantages of the bridge-way rectifier. The main disadvantage of the bridge-way rectifier is the use of 4 diodes as compared to that of the 2 diodes in the normal full-wave rectifier, and this causes additional voltage drop as indicated by the term 2RF. This reduces the output voltage. Now let us see the most important one, that is the comparison between the 2 diode rectifiers. Now if you see here, this is the full wave rectifier using 2 diodes, which is called as the center tapped rectifier, whereas this is the full wave rectifier using the 4 diodes, which is called as a bridge wave rectifier. Now let us see the comparison between these 2 diode rectifiers one by one. The first one is, in the case of center tapped rectifier, it makes use of center tapped transformer, whereas in the case of the bridge wave rectifier, it does not use the center tapped transformer. The next one is, in the case of center tapped transformer, one diode conducts in each half cycle of the input signal, Whereas in the case of the bridge wave rectifier, two diodes conduct in each half cycle of the input signal. The next one is the voltage drop across the diode is due to the RF only in the case of the center tapped rectifier, whereas the voltage drop across the diode is due to 2 RF in the case of the bridge wave rectifier. The next is the output voltage is more in the case of the center tapped rectifier, whereas the output voltage is less in the case of the bridge wave rectifier. The next, the transformer is less effectively used in the case of the center tapped rectifier, whereas the transformer is used more effectively in the case of the bridge wave rectifier. The next one is the transformer utilization factor of the center tapped rectifier is 0.693, whereas the transformer utilization factor of the bridge wave rectifier is 0.812. And the last one, the peak inverse voltage rating of the diode is equal to 2 ESM in the case of the center tapped rectifier, whereas the peak inverse voltage rating of the diode in the case of the bridge wave rectifier is equal to ESM. So these are some of the important comparisons between that of the two diode rectifiers. Finally, there is a quiz for testing your knowledge. Click on the link below so that you will be directed to the Google form quiz. Hope you like this video and understand the concept of what are the important comparisons between the center tapped full wave rectifier and the bridge full wave rectifier.